Theorem 1 said that we did Theorem 1 before you started with exams. If you have a triangle and you draw one line parallel to one side of that triangle, then we can divide the other two sides in the same proportions. Can you remember that? Like for instance in this example, AD divided by DB will have the same answer as AE divided by EC. Are you all with me? Okay, that was Theorem 1. Now we get to Theorem 2, today's work. And I don't give you just one triangle, I give you two triangles. And if these two triangles are equal angular, it means angle A is the same as angle B is the same as angle E, and angle C is the same as angle G, so they are similar. So if the triangles are equal angular, then they are similar. Now you can remember in grade 8 and 9 we did similar triangles. And the reason was, if two triangles are similar, it's angle, angle, angle. Now this theorem is the proof of that. Okay. So I give you two triangles, the big one and the small one, with the three angles that are equal. And you have to prove the ratio of the angles. So you have to prove that AB over DE equals AC over DG equals BC over EG. Okay. Theorem 1 was, there was one triangle with a parallel line parallel to another side, and then we can use these proportions. Now we have two triangles, and now we want to use the proportions. So, we have a construction. We draw a line HI so that AH equals DE and AI equals DG. Okay, so we actually draw the same green triangle inside the big one. Now we first have to prove that this green triangle and this red triangle are congruent. By doing that, we say AH equals DE, angle A equals angle D, and AI equals DG. So now we have side, angle, side, and then we have congruency. So that means this green one is exactly the same as the red one. When we have that, we can then say that this angle H will be equal to angle E because of the congruency, and angle I will be equal to angle G. But we know that angle E equals B, therefore H is also the same as B. Are you with me so far? But these two angles are corresponding. Therefore, this line is parallel. And then we get to Theorem 1. If you have a side that's parallel to another side, you can use the proportions. So now we say AB over AH is the same as AC over AI. Okay? Yeah?
What did you say the reason was for H being equal to B before Theorem 1?
We said that H equals E because of the congruency, but in the beginning we said angle E is the same as angle B. Therefore H will be same as B. Okay. but they are corresponding, therefore those two lines are parallel. And then you can say AB over AH is the same as AC over AI, and you can say that because these are the same, you can, instead of saying AB over AH, you can say AB over DE. And because those two lines are the same, instead of saying AC over AI, you can say AC over DG. Are you all following me? So now I can do the proportions for two triangles, not only for one. That is theorem 2. Now let's look at an example. We have two triangles. Two angles are the same. The third one we don't know. And we have to solve x and y, so the side lengths x and y. First, you need to prove that these two triangles are similar. So, angle Q equals angle L, angle S equals angle M, and because two angles in two triangles are equal, the third one will automatically be also equal because of the interior angles of a triangle. Right. Once you've proved that, we use the proportions of similarity from grade 8 and 9. KL divided by PQ equals LM divided by QS equals Km divided by Px. Can you remember that? We also did that in the winter school. Okay? So that's what I did there. And I chose KL because it has the variable. So KL over PQ equals LM over QX. These two are known and there's a variable, so I have to choose that one. Then you substitute the values. Cross multiply and you get y. You also do the same for PS. PS over Km is the same as QS over LM because there's my variable, so I use the same side and these two sides are known. You substitute the values, cross multiply, and then you get x equals 3. Are there any questions so far?
Yes.
Yeah.
Ma'am, why are we doing this? What was the question?
The question was, determine the length of PS and the length of KL.
And then where did we get the 3,1?
They give it to you on the graph, on the picture.
Oh, I see.
So you always have to start by proving that they're similar.
You always have to start proving similar if there are two triangles. So, example 2, we have a circle with a tangent and we draw a huge triangle. Now they ask, prove that triangle ACD, so it's the big red one, is similar to the blue one. To prove similarity, you need three angles. Okay. Angle C in the blue one is the same as angle A in the red one because its angle between a tangent and a chord is equal to the angle in the opposite circle segment. Angle D in the blue is the same as angle D in the red. And now I have two angles, so the third one is by definition equal. Therefore, and triangle ACD is similar to triangle CBD. Now what's important when you prove similarity? angle A in this triangle must correspond to the angle that's equal to it. So it's just A is the same as C in the other triangle. Angle C in the red one is the same as angle B in the blue one. And angle D in the red one is the same as angle D in the blue one. So it's very important that these angles are in the same order as they are equal. Yeah.
I don't think I followed the C angle. You said that angle BCD is equal to BAC. BCD equals to BCD is equals to A. Okay, yeah. So what's the reason, right? Because of
Triangle ACD. Are you here?
no, ma'am. The first reason.
This
yes,
one?
Yes, ma'am.
Okay. Angle A in the red equals angle C in the blue. Because there's a tangent and a chord. The angle between a tangent and a chord is equal to the opposite. Okay.
And then T is our common
Common
And
angle.
hence you can say
Therefore, yeah.
Okay.
Okay. Now that we've done number A, number B asks you, prove that DC squared equals DB times DA. This comes from the similarity that you've just proven. Now I'm going to show you a trick on how to get to that. You need two DCs or CDs. So in your similarity statement, you look for CD and CD. There's a CD and there's a CD. So I have two CDs or DCs. Sorry. Then you look for DB. There's a DB or BD. And then you look for DI or ID. There's an ID. And the picture on this side, must look the same as the picture on that side. Then you can work with your proportions. Now you say CD over BD equals AD over CD. Okay? And then you cross multiply. Then you get CD times CD is CD squared equals BD times AD. And that's what they asked. Do it again, okay? I have to look for two DCs, but you can swap the names as well, CD or DC. So there's one CD, and there's another CD. Okay? Then I look for DB or BD. And then you look for DI or ID. Now this picture must look the same as that picture. If they look the same, you're great. Now you say AD over CD equals CD over BD. And then you cross multiply.
I don't understand that.
Okay. I'm going to leave this. I'm going to switch off the homework. I'm going to switch off the recording and then I'm going to give you time to copy everything.